Now you can see we have kept some clearance values between the gears and the teeth. Select this inside surface of gear and click on OK. So this way we have meshed our gears properly. Now select this surface and select the outside surface of shaft. So after coloring this component, the component will look like this. So hello guys and welcome back to our channel Simple Random Knowledge. So guys, in previous video we have seen how to design and assemble EOT crane snatch block. If you have not watched that video, then you will get a link of that video in our description as well as in I button. In today's video we are going to see how to design and assemble gear pumps. So you can see the animation video in front of you. We are going to design all the components that you can see in this video. But before moving towards our video, there are around 70% of people who are watching this video, but they haven't subscribed to my channel. So I genuinely request to all you guys that please to subscribe to my channel and press the bell icon near it. So without wasting any more time, let's start with today's video. So guys, we are going to start with the designing of a component with the first component as a spur gear. So for designing the spur gear, we are going to take a help of design library. So at your right side, you will get this option of design library. In this, select on this toolbox. If you have not added your toolbox yet, you will get this kind of option. Just select on add in now. And after a few minutes, you will get this kind of folders. Just scroll down and search for ISO. Just double click on this ISO. Now we are supposed to design the gears. So search for this power transmission. Select on this gears. Now you will get different kind of gears. Among this, select on this spur gear. Right click on it. Select on create a part.
A few moments later.
So after a few minutes, you will get this kind of interface. At your left side, you will get this configure components window. In this, we are supposed to define the properties of our spur gear. So just scroll down. You will get the first property of module. Before moving towards this module, first we select the number of teeth. In my case, I have assumed the number of teeth as 13. After assuming the number of teeth, we are supposed to calculate the module. So I have got the module around 5. So I will select here 5. Then I have selected the pressure angle as 20. And if you have studied these gear pumps, you must be knowing that the face width of this spur gear is 7 times of the module. So multiply 7 with this module, you will get 35 mm as a face width. Scroll down, you will get some more options. Then we have hub style. I have selected as type A. Then we have nominal shaft diameter. After doing the calculation for the shaft, I have got the nominal shaft diameter as 22 mm. So I have selected as 22. Then if you want a keyway, you can select a keyway from this option. So I have selected rectangular 1. So after this, click on OK and your spur gear is ready. So if your dimensions are different and they are not mentioned in the properties, you can change the dimensions from this tree. For example, if you want to increase the bore diameter, what you can do is go to this bore, right click on this bore sketch, select on edit sketch. So you can edit the diameter of this bore. Right now I don't want to edit any dimensions. So just click on cancel and exit this sketch. So this way my spur gear is ready. Now save this part as a spur gear. Go to save as. So I have created one folder in desktop naming as GearPump. So I will save this component as a spur gear and click on save. Now after designing the spur gear, we move towards our second component, which is the shaft. So just close this window, go to new, select a part, click on OK. Now first select top plane, select normal to, go to sketch, select circle and draw circle on origin. While sketching any geometry in Solidworks, make sure that geometry is defined with respect to origin because that will be helping you while assembling that component. Now go to smart dimension, select this circle and give the diameter of this circle as 22 mm because while designing the spur gear, we have selected the nominal shaft diameter as 22 mm. So just click on OK, go to features, select extruded boss. Now if you have done the calculation, you all must be knowing the length of the shaft is 2 to 2.5 times of the width of a gear. So in my case, the face width of the gear was 35 mm. So I will get the length of the shaft around 70 to 90 mm. So I will select 70, click on OK. Now our shaft is ready, but one thing is missing, which is our key. So select this face, select normal to, go to sketch, select the edge of this circle and go to option convert entities. Now go to center rectangle and draw the rectangle at the top point of this circle. Give the length of this side as 8 mm and the distance between this center point up to this line as 3 mm. Click on OK. Now go to trim entities and trim the unwanted parts. Click on OK. Now go to features, select extruded boss and extrude it up to 40 mm in reverse direction. Click on OK. So this way our shaft got ready. So save this component as a shaft. Click on save. Now we are supposed to design the driving shaft. Now what is the difference between driving shaft and driven shaft? Driving shaft length is more as compared to driven shaft because driving shaft is extended outside this gear pump which is attached to the motor. So for that what we can do is just right click on this boss extrude, go to edit feature and increase this length up to 100 mm. Click on OK. So our driving shaft is ready. Just go to save as and save this component as a driving shaft. Click on save. Now close this component and now we move towards our fourth component which is needle roller bearings. Now for designing the roller bearings we are going to take a help of the design library. So go to design library again. Now go to this ISO, select here bearings. Now the needle bearings are the type of a roller bearing. So click on roller bearings, select a needle bearings, right click and select option create a part. Now we are supposed to define some properties. Now in my case, the bore diameter should be equal to 22 mm because the shaft outer diameter we have selected as 22 mm. So for that I am going to select 492239 bearings. So you can observe the bore diameter is 22 mm, outer diameter is 39 and width is 17 mm. So scroll down, you will get some more options. Number of rollers you can select as 20 or full. So I am going to select as full. Here the display you will get two options as simplified and detail. In simplified you will not be able to see the needles inside these bearings, but in the detailed display you can see the needles inside these bearings. Then you will get an option whether you want a cage over these bearings or you don't want it. So if you add the cage you can see your bearings will look like this, but right now I don't require it, so I will select no cage and just click on OK. So if you don't get any size of bearings from the presets, what you can do is you can edit the size from these options or you can search for the CAD on the SKF bearings website. If you don't know how to search for the CAD, I will post a link of that website in my description. And if you have any more doubts, just comment below. I will try to make one video on it. So now save this component as a bearing. Go to save as and make sure you don't save this component in a copied part. You save the component in a desktop, gear pump and name this as bearing. Click on save. Now we move towards our next component which is bolts. So just close these components. Now for designing the bolt, we are going to take a help of design library again. So go to this design library, just go to ISO, select bolts and screw, select hexagonal bolts and screw, select the first bolt, right click on it, select option create a part. Now as per the calculations you must be knowing, if the pressure is below 30 bars, you are supposed to select M12 bolt. So I am assuming my pressure below 30 bars. So I will select M12 as a bolt. Length of the bolt I am selecting as 50 and the thread length as 30 mm. Now here you will get three options as simplified display where you will not be able to see any threads. Then you have cosmetic where you will get some blurry kind of view, and last you have schematic. I will suggest you to keep this as schematic and click on OK. Now go to the save as option and save this component as a bolt. Now we move towards our next component which is nut. So just close this component. Go to this design library again. Go to this ISO. Select nut. Select hexagonal nut. Right click on this hex nut grade C. Select option create a part. Now we have selected M12 as a bolt. So we are supposed to select the nut size as M12. And same option you will get here. Simplified, cosmetic and schematic. Keep this as schematic and click on OK. Now go to this save as again and save this component as nut. Now we move towards our last two components which are the main component of our gear pumps. So just close this component and now we start with our casing. So just select new part, click on OK. So first select this front plane, select normal to, select sketch, select midpoint line and draw line vertically downwards. Go to smart dimension and give the length of this line as 64 mm. Select this line and select here for construction purpose. Click on OK. Now go to the straight slot and draw your slot from this point up to this point. Now go to smart dimension option and give the radius of this slot as 62.5 mm. Now go to this features option, select extruded boss and extrude it up to 20 mm. Click on OK. Now select this surface and select option sketch, select normal to, select midpoint and draw this midpoint vertically downwards. Go to smart dimension and give the length of this line as 64 mm. Select this line, select your option for construction purpose, click on OK. Go to this circle, draw two circles, one at this point and another circle at this point. Go to smart dimension and give the diameter of this circle as 75 mm. Select this circle, press Ctrl key, select this circle and give the relation as equal. Click on OK. Now go to this trim entities and trim these unwanted parts. Go to features, select extruded cut and cut this up to 17.5 mm. Click on OK. Now go to backside, select this surface, select normal to, go to sketch, select midpoint line and draw line vertically downwards. Go to smart dimension, give the length of this line as 64 mm. Select this line and select here for construction purpose. Click on OK. Go to this straight slot and draw slot from this point up to this point. Now go to smart dimension, select this top point and then select this bottom point and give the length as 140 mm. Click on OK. Go to features, select extruded boss and extrude this up to 20 mm. Click on OK. Now go to this backside again, select normal to view, select sketch again, select midpoint line, draw midpoint line vertically downwards. Go to smart dimension, give the length as 64 mm. Select this line, select here for construction purpose, click on OK. Select circle, draw circle at this point and another circle at this point. Go to smart dimension, give the diameter of this circle as 39 mm. Select this circle, press Ctrl key and select this circle, give the relation as equal. Click on OK. Go to features, select extruded cut and cut this up to 17 mm. Click on OK. So basically the bigger slot is for our gears and the smaller slot is for our needle bearings. Now we are supposed to make a hole for our bolts and nuts. So just select center line and draw the center line vertically upwards. Again go to center line and draw one more center line horizontal and again go to center line and draw one more center line at 40-degree angle. So for giving the angle, select this line and select this vertical line and give the angle as 40. Click on OK. Go to circle and draw circle vertically upwards and one more circle at this point. Now select the center of the circle and select this line by pressing Ctrl key and give the relation as coincident. Click on OK. Now go to smart dimension, select this circle and give the diameter of this circle as 12 mm. Click on OK. Select this circle, press Ctrl key and select this circle and give the relation as equal. Click on OK. Now adjust this circle to the center and same way adjust this circle. Now go to this mirror entities option, select this circle and mirror about this vertical line. Click on OK. Now again go to this mirror entities option, select this circle and last select this circle and select mirror about this horizontal line. Click on OK. Now go to this features, select extruded cut and select option through all both. Click on OK. Now the last extrude cut is remaining, which is at this point. Select sketch. This cut is for our driving shaft. Select smart dimension and give the diameter of this circle as 22 mm. Go to features, select extruded cut, select through all both. Click on OK. So this way we have completed with our casing. So save this part as a casing. Click on save. Now we are supposed to design the end cover. So for designing the end cover, just delete this extruded cut and go to save as and save this component as an end cover. Click on save. So this way we have done with designing of all the components which are required for our gear pumps. So close this component and now we move towards our assembly. So select your assembly, click on OK. So first insert our casing, click on open and place it over here. Right click on this component and select option float. Now go to mate, open this arrow and open this arrow also. So basically these are the planes of our assembly and these are the planes of our component. So just mate this front plane of our assembly with the front plane of our component. Click on OK. Same way mate the top plane and last the right plane. So this way we have aligned the component to the origin of our assembly. Now go to insert and insert our next component as a bearings. Press Ctrl key and drag this bearings. Go to mate, select the inside surface of this bearings and outside surface of this casing. Click on OK. Then select this outside surface of bearings and select this surface of casing. Click on OK. Same way, select this bearings, inside surface and outside surface of this casing. Click on OK. Then select this outside surface of bearing and select this surface of casing. Click on OK. So this way we have placed our needle bearings inside our casing. So click on OK. Now next insert our spur gear. Click on open. Same way press Ctrl key and drag this spur gear to make the copy of this spur gear. Now go to mate. Select this inside surface of gear and inside surface of this bearing. Click on OK. Drag this gear at some distance. Select this surface of casing and backside surface of this gear and give the distance as 0.1 mm. Click on OK. We have kept some clearance between casing and gears. So same way select this surface and backside surface of this gear and give the distance as 0.1 mm. Click on OK. Select this inside surface of spur gear and inside surface of this bearing. Click on OK. Now select the front view. Now if you observe, the spur gears are not meshed properly. So adjust this teeth of the spur gears. Now you can see we have kept some clearance values between the gears and the teeth. So after adjusting the gears, go to the mechanical mates, select gears, select this inside surface of gear and inside surface of second gear and click on OK. So this way we have meshed our gears properly. Now close this mate. Now go to insert component and insert our shaft. First we insert our driving shaft. Click on open. Adjust the view. Go to mate. Select the outside surface of the shaft and inside surface of this gear. Click on OK. Then select this surface of a key and inside surface of this gear. Click on OK. Now close this mate. Go to insert component again and insert our normal shaft, which is our driven shaft. Change the positioning. Now go to mate. Select the outside surface of this shaft and inside surface of this gears. Click on OK. Now select this inside surface of key and inside surface of this gear. Click on OK. Now drag this shaft at some distance. Select the inside surface of this casing and backside of this shaft. Click on OK. Now select this surface and select this surface. Click on OK and close this mate. Now before moving towards our next steps, make sure you have saved this component because Solidworks can crash at any moment. So for safer side, save your component after every 5 minutes. Now again go to insert component and insert our end cover. Change the direction. Now again go to insert component and insert our bearings. Press Ctrl key and drag this bearing. Now go to mate. Select this inside surface of bearings and outside surface of this casing. Click on OK. Same way select this inside surface of bearing and outside surface of this casing. Click on OK. Now select this surface of bearing and this surface of casing. Click on OK. Same way select this surface of bearings and this surface of casing. Click on OK. Now select this surface and select the outside surface of shaft. Click on OK. Same way select this surface and select this inside surface of bearings. Click on OK. Now select this surface and select this surface. Click on OK. Now in this case you can design the seal in between these two covers, but right now I have tried to keep this assembly as simple as possible. So just close this mate. Now again go to insert component, select our bolt and press Ctrl key, select our nut. Click on open and place both of the component over here. Now first of all make the 6 copies of this component. Press Ctrl key and drag this component to make the copy. One more copy is left. So this way we have created 6 copies of each component. Now go to mate. So select this outside surface of bolt and this circular surface of the nut. Click on OK. Follow the same procedure for all the nuts and bolt. Now next thing is select this surface and select the inside surface of this casing. Click on OK. Drag this bolt at some distance. Select this surface of casing and select the back side of this bolt. Click on OK. Then select the surface of casing and front surface of this nut. Click on OK. Now repeat this procedure for all our nuts and bolts. So after completing these steps, just click on OK and save this component again. So we have done with the design and assembly of a gear pump, but that's not the end of this video. Now we are going to see how to animate this assembly. So go to motion study option. First drag this up to 14 to 18 seconds or keep this as 20 seconds. Now we have designed the driving shaft. So we are supposed to attach the motor to this driving shaft. So select your motor, select this driving shaft and set this RPM as default 100 RPM. Click on OK. Select the speed as 1x. Right click on this component and make this component as transparent so that we can observe the inside components and press calculate.
A few moments later.
So after completion of calculation, you can try to play this video. Now the main thing which is remaining is that we have not provided the inlet and outlet for this casing. Close this motion studies, select this component, right click on it and open this component. Now select the plane as a right plane, normal to, go to sketch, select circle and draw the circle at this point. Select smart dimension and give the diameter of this circle as 20 mm. Click on OK. Go to features, select extruded cut and select option through all both. Click on OK. So save this component and close this component. So Solidworks will ask you whether you want to rebuild this assembly. So click on yes. So we have got the hole at this casing. Same way we are supposed to create a hole at this casing. So just click on open a part. So we have provided the inlet and outlet hole. Now again go to this motion study option. Click on this arrow and again click on calculate.
A few moments later.
So after completion of calculation, just try to play this video. Basically this is the inlet of the gear pump and this is the outlet. Now we are going to see how to use this extruded view command. So just minimize this animation. Go to this extruded view. Now select all these bolts by pressing Ctrl key. Click on this arrow and drag these bolts outwards. Now select this casing, drag this casing outwards. Now press Ctrl key, select this needle bearing and select this second needle bearing, drag this outward. Select this gear, press Ctrl key and select this second gear, drag this outwards. Select this shaft, select this second shaft, drag outwards. Now select this bearing and select this second bearing and drag this outwards. Now go at the back side and select all these nuts. Press this arrow and drag this outwards. So this way we have exploded this view. So click on OK. Select this gear pump, right click on it, select collapse. Now go to motion studies. You will get the option of animation wizard. Select explode, click on next. Select duration as 7 and 1. Click on finish. Then again go to animation wizard. Select a collapse, select next and select duration as 8 by 8. Finish. Now just try to calculate this. So this way we have completed with the animation of exploded view. So save this assembly. Click on rebuild and save the document.
A few moments later.
So after coloring this component, the component will look like this. And this is the motion study that we have done right now. I hope that you have enjoyed this video. Please hit that subscribe button and press the bell icon near it, and share this video among your friends. And if you have not watched my previous videos, you will get a link of that videos in our description as well as in I button. So until our next video, stay safe and happy learning. Thank you.